Okay, this lesson is on squares and square roots. The first thing that I want you to do is get a couple of vocabulary words down in your ISNs. The first is perfect square. Okay, get that down in the P's of your glossary in the back. And then the next one is square root. Turn to the S's and get that in. All right? Okay, I gave you two study guides today. I gave you 3-1 and 3-2. They should both be glued down to page 15. Both of them need to be glued down on a tab because you're going to do some writing underneath. Okay? For lesson 3-1, squares and square roots, the main thing that I want to get across to you is that the reason it's called a square, or squaring a number, and it has to do with this geometric figure, which is a square. Okay? Let's say I have a square and it has a side length of 6. Okay? Because it's a square, the definition of a square means that all of the side lengths are 6. Right? Okay? Squaring a number has to do with finding the area of a square. The area of a square is length times width. Okay? And in the case of a square, the length and the width are both the same number. Okay? So when we find the area of the square, we multiply a number times itself. That's why it's called squaring a number. Okay? It's not just something that some mathematician made up. There is a mathematical reason why multiplying a number times itself is called squaring a number. Now the opposite would also be true. Let's say I have a square and I tell you that the area is 81. Okay? That means that its side times its side has to equal 81. So if you're given the area, you should be able to find the side length of the square, which is the same thing as finding the square root. What number times itself equals 81? That would be 9. 9 times 9 is 81. Okay? That's the main thing that I want to get across to you when we're talking about squares and square roots, is that it all has to do with the properties of a square. All right? Now, somewhere underneath your tabbed study guide, give yourself a teacher-student column. And we're going to work some of those study guide problems together and then independently. All right. Look at number 1. It says square root of 4. All right? This is the square root radical. Kind of looks like a division sign, except it's got the little check mark in the front. It's called a square root radical. It means what is the square root of 4? What number times itself equals 4? Well, it would be 2, because 2 times 2 is 4. Okay, number 2. Need to know the square root of 9. Okay, the square root of 9 would be 3, because 3 times 3 is 9. All right? Look at number 3. It says the negative square root of 49. That equals 7. Right? But they want the negative square root. All numbers that are perfect squares actually have a positive and a negative square root, because 7 times 7 is 49, but also negative 7 times negative 7 is 49. So when they put the negative sign here, they're specifically asking you for the negative square root of the number. Okay? Let's get down to number 7. It says the square root of 9/16. All you have to do is find the square root of both the numerator and the denominator. The square root of 9 is 3. The square root of 16 is 4. So the square root of 9/16 is 3/4. All right? So on the student side, I want you to do these problems. Let's do number 4, which says the negative square root of 25. Let's do number 5, which says the square root of 0.01. Let's do number 6, which is the negative square root of 0.64. And let's do number 8, which says the negative square root of 1/25. Okay, do those 4 problems from this lesson, and then I want to skip over to 3-2, which talks about estimating square roots. All right, under 3-2, give yourself another teacher-student column. And now we're going to estimate square roots for numbers that don't have a perfect square root, because most numbers are not perfect squares. There's only a few numbers that are perfect squares. Your perfect squares would be 1. 1 times 1 is 1. The next one would be 4, because 2 times 2 is 4. The next would be 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and so on and so on. But most numbers are not perfect squares, so we have to use estimation. If you look at number 1, it says square root of 8. What I'm going to do is I'm going to find the perfect squares that are just below the number and just above the number. Okay? The first perfect square, the closest perfect square to 8 that I can think of is the square root of 9. Okay? The one right below the square root of 8 will be the square root of 4. Okay? The square root of 4 is 2, and the square root of 9 is 3. So the square root of 8 is somewhere between 2 and 3, right? Square root of 4 is 2, square root of 9 is 3. It's going to be closer to the 3. My estimate would be 3, because 8 is closer to 9. All right? Look at number 2. Square root of 37. Well, just above it, just below it, I've got square root of 36. That's 6 times 6. And to the other side, I've got 7 times 7, which is 49. So the square root of 37 is somewhere between 6 and 7. But because 37 is closer to 36, my estimate is going to be 6. All right? Look at number 3. Square root of 14. Just below it, I believe we're going to have the square root of 9, 3 times 3. And just above it, 4 times 4, square root of 16. So the square root of 14 is going to be somewhere between 3 and 4. Okay, 14 is closer to 16, so my estimate's going to be 4. Okay, if I do one more down here, can you see it? Okay, I want to skip down to the ones down there at the bottom with the decimals. Now, just because there's a decimal in the problem does not change your process at all. Look at number 10. It's the square root of 51.2. Okay? Just below that, I've got the square root of 49. And above it, the square root of 64. This is 7 times 7. This is 8 times 8. Okay, so it's somewhere between 7 and 8. Okay, it's going to be closer to the 7, because 51 is closer to 49. So my estimate would be about 7. All right, so let's do a few of these on the student side. Let's do square root of 26. Let's do square root of 62. Number 6, square root of 48. And then we'll do one of those with the decimal. Let's do number 11 at the bottom, square root of 82.7. Okay, there's your student problems. Before we go, I do need to do my shout outs. I've got, thank you. Chizerum, Jackson, and Ashley. Congratulations. See me tomorrow for your prize. Turn it off.